Welcome to our Proteus Pitch Finale. Thank you very much for joining us today. My name is David Muir. I'm at Western, Associate VP of Innovation, and I will be your host today. Before we start, I'd like to give a couple of housekeeping notes. First of all, we kindly ask you to keep your microphone muted during the entire event. Secondly, a reminder to our teams that you have 5 minutes to pitch, and we have a 5-minute question component. For those all teams will have 5 minutes to answer questions following their presentations. If any in the audience do have a question, please post it in the chat, and we will answer them or ask them in the order in which they are received, up to a 5-minute limit. I'd like to start with acknowledging the land on which we're gathered. I know we have guests and participants from across Ontario, so I will give an acknowledgement specific to my location in London, Ontario. Western University is located on the traditional territories of the Anishinaabe, the Haudenosaunee, the Lenape-Awak, and the Chinookan nations, on lands connected with the London Township and Sombre Treaties of 1796 and the Dish with One Spoon Covenant Wampum. This land, as well as all the land on which we're gathered, continues to be the home to diverse Indigenous peoples, including First Nations, Métis, and Inuit, whom we recognize as contemporary stewards of the land and vital contributors to our society. First off, to give our opening remarks, I would like to welcome Dr. Brian Neff, Acting VP Research at Western University.
Okay, thanks, Dave. Not able to turn on my video, but that's okay, I guess. So good afternoon, everyone, and welcome to the finale of the 8th Annual Proteus Innovation Competition. We are proud to see this program grow each year and are grateful to have you all join us today. I have no doubt that our participants have learned a lot about the technologies that they have been working on, but hopefully also a bit about themselves and their colleagues. Thanks, Dave. I want to wish you all good luck and congratulate you on your collaborative work throughout the abstract and business plan stages of the competition. The finale is always an exciting event that gives us an opportunity to see you pull together the threads of your ideas, innovations, and learnings from the past 4 months. We're also impressed by how polished the pitches are. No pressure here. I hope you have had a great experience. I would like to express my deep thanks to each of the investigators who have provided a technology for this year's competition, including Western's own Subrata Chakrabarty, who has created a diagnostic marker for diabetic retinopathy, Philip Britz McKibben from McMaster, who has put forward a method for vitamin D screening, Windsor's Tricia Carmichael, who has brought stretchable and wearable composite electrodes. From Guelph, Abdallah El Said, who has created a high-strength, high-conductivity aluminum alloy. And Juan Liu, who has brought from Waterloo DNA aptamer biosensors for lactate detection. When this competition began, it only included local technologies, so I'm thrilled to see it has grown to include you all as partners. We must continue to strengthen regional networks of research, innovation, and entrepreneurship, and to leverage each other's expertise. I applaud the Proteus team for heading down this road, literally and figuratively, as it is how we can collectively have impact in our communities and around the world. As many of you know, these themes are woven throughout Western's new strategic plan towards Western at 150, which describes efforts to foster relationships, to learn by doing, and to develop a culture of continuous innovation. This initiative is a great example of our capacity to foster collaboration and to nurture a spirit of entrepreneurship among students and researchers, while showcasing outcomes of Ontario University research. In closing, I would like to thank the World Discoveries team for stewarding this program and our mentors and innovators who have shared their time, expertise, and technologies with us. Thank you. I'll pass it back to you, Dave.
Thank you, Brian. Thank you for your comments. Today, we're gathered for the 9th annual competition of this award, along with our founding and competition partners, who include Tech Alliance of Southwestern Ontario, World Discoveries, Western Research Parks, and Western's Morissette Institute for Entrepreneurship, as well as the universities that participate from Southern Ontario in the Proteus competition: the University of Waterloo, the University of Guelph, McMaster, and Windsor. Welcome and thank you to all of you. Next, I would like to thank our kind sponsors whose financial contribution to this event provides the prize for the competition winners that you will see shortly. Western's Morstead Institute for Entrepreneurship, Gowlings, IAC, the Innovative Asset Collection, Explorer, and Life Sciences Ontario. Thank you very much for your kind support. Your participation makes this event able to happen. So, without further ado, I'd like to present our round one judges to be evaluating the first round of our competitors' pitches. John Pollock from JMP Consulting, James O'Reilly from Arrayus Technologies, and Susan Tandon from Gowling. Thank you. So are we ready with our first presenters from Western?
Yes, I'm just going to stop sharing the other person's screen. That's okay. All right, so hi everyone, my name is Jennifer and I'm excited to be here on behalf of my team to tell you more about our company, iRNA. So diabetes is a silent yet rapidly growing epidemic that affects over 530 million people worldwide, growing at a rate of 10 million every year. Diabetes comes with a host of other complications that can be life-altering, and one of the most devastating of these is diabetic retinopathy. DR occurs when a high glucose environment in the eye causes abnormal blood vessel formation and bleeding that can lead to vision loss. DR affects nearly all patients with type 1 diabetes and more than 60% of patients with type 2 diabetes, making it the #1 leading cause of blindness worldwide. The challenge is most patients would not know they have retinopathy until their vision starts to look like this, and they are prompted to visit an eye doctor for a diagnosis. At this late stage, the only option for patients is treatment, which is costly, highly invasive, and not effective in nearly 50% of patients. The goal is to detect retinopathy in the early asymptomatic stages, before any vision loss. So upon initial diagnosis of diabetes, patients are urged to visit optometrists annually for an eye exam. DR is a progressive disease, and eye exams hope to detect retinopathy in the mild non-proliferative stages. Unfortunately, our research has found that many patients are diagnosed at the more severe stages where treatment is required. Now, what's important to note is that eye exams screening for DR are looking for structural damage in the eye. However, years preceding these symptoms are the cellular changes that induce the structural damage. So the question becomes, how can we identify the cellular changes? Well, that's where iRNA comes in. With a simple blood test and PCR technology, we have identified a panel of biomarkers in the blood associated with retinopathy. The coupled risk assessment algorithm allows monitoring of these biomarkers and can reduce the burden on the healthcare system by stratifying patients as high or low risk and guiding those high-risk patients to seek more specialist care and low-risk patients to continue monitoring. To generate revenue, iRNA will sell assembled biomarker kits and access to the risk assessment algorithm to labs and hospitals that already collect and analyze biological samples with qPCR testing. The cost of our test will be covered through partnering with healthcare plans and insurance companies to improve accessibility to our users. We will also be providing a subscription-based model for iRNA Plus, which is an app that allows patients to conveniently monitor their biomarker levels and be alerted when levels suggest a high risk. Now, our screening tool can be easily integrated into existing checkups with family doctors and diabetic specialists, since patients are already monitoring their A1C levels with a blood test every 3 months anyway. So the current standard for screening retinopathy is an annual comprehensive eye exam. Can you see a problem with that? Patients often do not go get an eye exam until they are having vision problems and their disease is already in a late stage. Also, eye exams are subjective, costly, can be inaccessible to some, and overall an unfeasible option for all diabetics due to the volume of patients. IRNA offers a more cost-effective, feasible, and accessible screening option that will increase patient compliance to frequent screening, and most importantly, be able to provide an earlier diagnosis for retinopathy. In 2018 alone, Medicare spent over $800 million on diabetes-related blindness, and early detection of DR reduces the chance of blindness by 95%, which can save over $500 million in the management of retinopathy. Our target end users are all patients with diabetes, as they are all recommended to screen at least annually for retinopathy. We believe our technology will benefit newly diagnosed patients, patients with diabetes but no retinopathy, and even those with retinopathy that are undergoing treatment to ensure their disease does not progress any further. The market size in Canada is 5.7 million people, with a market value of $344 million. In North America and globally, these numbers are huge and are expected to continue to increase rapidly with the rising prevalence of diabetes, the growing aging population, and the increased rates of obesity. Our patent-protected technology is simple and effective to carry out, and acting now would allow our company to leverage the existing testing infrastructure of COVID-19, including the lab space, the PCR equipment, and trained healthcare workers. Our interdisciplinary team brings together diverse perspectives to inform the solutions for patients with retinopathy. Our mission is to have a world where DR is no longer a leading cause of blindness, and patients can be identified and treated early. IRNA will improve patient outcomes, reduce the clinical and economic burden of disease, and increase patient compliance for prevention. Thank you all so much for listening.
Thank you, Jennifer, very much. And I would encourage, if there's any questions to ask, to put them in the chat. There is a question there, Jennifer, if you can read it. It's, can I self-test or must the test be done by a doctor?
So it's not self-testing. You would go get a blood requisition from a doctor, probably at the time where you're getting tested for your A1C levels. And then wherever you get your blood drawn, usually you would get your blood drawn for this as well.
Excellent, thank you. Any other questions from anybody on the line? Hearing none, thank you, Jennifer, very much for your pitch, and we will transition to the next team.
That's great. Thank you very much. I'll just take a moment to share my screen now. All right.
Can everyone see?
I think so. In that case, let's get started.
Perfect. Good afternoon. We are Team Visionary, and we're here today to present to you a novel sight-saving solution, Western University's long non-coding RNA panel for diagnosing diabetic retinopathy. So recently, you've been diagnosed with diabetes, but life goes on and you continue soaking up the beauty of life. But what happens if your world suddenly stopped looking the way it used to? This is how people with diabetic retinopathy, or DR, see the world. DR is a complication of diabetes that results in blurry vision and floating spots, with the penultimate stage being blindness. Currently, 463 million people are at risk for DR, and over time, 50% of these people will develop it. However, when detected early enough, treatment can help prevent severe vision loss.
The current gold standard for diagnosing DR is a comprehensive dilated eye exam, but this can only be performed by an ophthalmologist, a specialist eye doctor. At the moment, diabetics can wait up to 6 months to see an ophthalmologist because of poor accessibility, especially in rural areas. For example, there's only 5 ophthalmologists in PEI and 1,200 total in Canada. As a result, DR is critically underdiagnosed and undertreated. Luckily, there is a solution. Dr. Chakrabarty's lab has developed a diagnostic panel that uses long, non-coding RNA to diagnose DR without the need to see an ophthalmologist. Family physicians can order this simple blood test to determine if a patient has asymptomatic DR for a faster diagnosis and treatment.
Our panel provides distinct advantages. Firstly, a proactive treatment for DR can reduce the risk of blindness by 95%. Additionally, our panel is rapid. With the option to see your family doctor or a walk-in clinic, DR diagnosis can finally be accessible. Furthermore, it's scalable. Any medical lab can perform this quick blood test. And lastly, this is a unique solution. No other blood test exists to diagnose DR. The end receivers of the DR diagnostic panel are diabetic patients. Market size is over 2.5 million in Ontario alone, with cases increasing by 546 patients daily. The primary target for the panel are hospital and family physicians who are easier to access. And with over 46,000 family physicians, this panel could greatly improve health equity and accessibility.
Now, our criteria to select the best alternative was based on the financial feasibility, the scalability, and being able to develop long-term relationships with family physicians. Ultimately, we decided with option 1, to establish partnerships with academic hospitals to work alongside affiliated family medicine practices and laboratory services. Now, when we evaluated the growth prospects, we viewed academic hospitals as centers for innovation and training, enabling us to spread awareness and normalize the adoption of the panel. Now I'll dive right into the numbers. So alternative 1 assumes a price per use model, where activities in St. Joseph's Hospital and the London Health Science Centre will be the primary client bases. The initial investment is around $156,000. This would include lab equipment, R&D, and license and patent fees. Now, assuming the panel is well adopted within the City of London, we projected a positive NPV of $2.9 million within 10 years, providing a payback within 1 year. Now, to fund for the initial panel development, we'll be applying for grants that are around $57,000.
In our 5-year plan, our first focus is completing clinical validation. Preclinical trials are showing promising results, and a 500-patient study is being performed right now. Next, we'll introduce our product locally. As a Western School of Medicine invention, we'll leverage this connection and begin rollout in university hospitals. Their academic family medicine centers will be the first family physicians to use this test, while the hospital lab on site performs the necessary blood work.
Now, to scale this product, we'll then partner with family medicine residency programs to train new doctors. As well, testing capabilities will then be expanded to private and industry medical labs to meet higher demand. Then we'll finally internationalize our product. We have the potential to become the standard diagnostic panel, something as routine as measuring blood glucose.
With our diagnostic panel, we provide millions of people with the opportunity to protect their vision easily. We are Team Visionary, and our vision is a clear future for all. Thank you.
Excellent. Thank you very much for your presentation. Do I have any questions? Are there any questions for the team from anyone in the chat? What is your, I assume that's what is your TAM?
Yeah, what is your total accessible market?
So if we can, so basically what we determined was within Canada alone, we have about a within Ontario alone is about a 2.5 million market size. Initially, with our projections, we assumed that 10% of that population would be interested in the technology. So we had a very conservative approach, but assuming that it is well adopted, not only be able to reach Ontario alone, but we can also reach within the Canadian population. And in terms of diabetic patients, it doesn't only include just people with diabetes, but people who are undiagnosed as well. And that's what we hope to do to normalize this practice within basic blood work testing.
Thanks.
Any other questions? Okay, I'm not seeing any, so I'll thank Team Visionary for your pitch. Thank you very much, and we'll move on to the next next university now, and that will be the University of Waterloo. Are we ready with lax sensor?
Yes, we are. We're good to go.
Thank you very much. Please go ahead.
Give me 1 second. I'm gonna get the slides pulled up. It says you cannot screen share while the other participant is screen sharing.
Okay, 1 second, we'll resolve that.
Okay, thank you very much. Okay,
There you are. Please proceed.
excellent. Thank you. Okay. Every day, we are constantly moving. Maybe it's walking to school or going for a run after work, or perhaps you're an athlete whose body is in constant motion. Whenever our bodies exercise, we are building a molecule called lactate, and buildup of this molecule results in fatigue. So why not keep track of this lactate buildup? Ladies and gentlemen, my name is Alvin Linus, and along with my partners, Selvin, Bowen, and Ilias, we are the team behind lax sensor. Now, with advancements in medical technologies, the average person can easily measure things like their blood glucose levels and their pulse. However, a versatile, accurate, and yet minimally invasive tool to continuously monitor blood lactate levels does not currently exist. But we have a vision of a world where everyone, from patients with acute and chronic illnesses to healthy individuals such as athletes, are now given a chance to improve and optimize their conditions to reach their health goals. Lax sensor is the solution to achieving that vision. Introducing lax sensor, the groundbreaking technology that will revolutionize the way that lactate is measured. Our DNA-based lactate sensors are coated onto the tips of microneedle patches, and you can easily stick them on your arm. And they offer continuous and real-time measurements of lactate levels. One of the key strengths of lax sensor is its high selectivity for lactate, and this allows for accurate and reliable results. Our system can integrate with various personal applications, such as your cell phone, allowing for direct, rapid, and continuous monitoring. This means that instead of having to wait hours at a lab, our patch can give you the same results from the comfort of your home.
Our competitors can be classified into two broad groups. One, established companies like Freestyle Libre, which do not offer continuous lactate monitoring, but could in the future based on their continuous glucose monitoring infrastructure. And two, startups like PK Vitality, which are currently developing lactate sensors, but with low sensitivity and requiring purchasing of their proprietary watch, which becomes quite expensive. Lax sensor is by far and large the most sensitive and specific technology in this field. Additionally, it is a hardware agnostic, meaning it can easily integrate with any SaaS product. It also allows for real-time monitoring, and this is particularly helpful for athletes and healthcare professionals. We are partnering with World Discoveries for help with initial patents, the American College of Cardiology and Canadian Cardiovascular Society to help generate public interest, and Starfish Medical as a medical device manufacturing and distribution partner. We'll incorporate as a startup and license our microneedle patch to Starfish Medical for 10 years for a 70% royalty on lax sensor sales. Our sources of revenue are insurance providers as well as uninsured patients wishing to monitor their blood lactate levels.
Now, in phase one, comprising years 1 to 3, we'll complete device development stages, establish our manufacturing and distribution partnerships, and finally generate public interest in our monitor. Now, in phase 2, we'll hit the market and begin generating revenue in the United States and Canada before filing international patents. And finally, in phase 3, we enter the international market with the goal of exit by acquisition. We've identified Abbott Laboratories as a potential buyer.
Years 1 to 3 involve budgeting $5 million for marketing, operational, and product development costs before we make any sales. Our financial projections are based on the 70% royalty we collect on a year's supply of a $15 microneedle pack. We expect to start earning revenue in year 4, capturing a modest 1% of the Canadian market for patients with chronic conditions such as shock, blood disorders, and sepsis, as well as professional and amateur athletes. In year 5, we capture an additional 1% of the US market. We've now moved past stages 1 and 2 and are currently on stage 3, the pathway to approval. Our device will be classified as a Class 2 device, which allows us to bypass the pre-market approval process, which would typically require phase 1 to 3 clinical trials, which are both costly and lengthy. Instead, we can provide a pre-market notification, a 510K, and by providing proof that our device is essentially equivalent to another similarly legally marketed device, such as Nova Biomedical's instantaneous lactate plus meter.
I will be serving as our VP Operations and Strategy, Selvin as VP Investor Relations, Bowen as VP Sales and Marketing, and Ilias as our Research Manager. Dr. Jiwen Liu is our Chief Scientific Officer. Today, we're seeking a $5 million investment in exchange for 33% equity in our firm. Half of these funds will be put towards product development, with the remaining divided between marketing and operational expenses. Thank you all for your time.
Thank you very much, Alvin and team. Thank you, Lock Sensor. I'll now open the chat or open the floor to questions. Are there any questions from any of the audience members?
Yeah, give me just a second here.
James, you can just say it if it's easier.
Yeah, it's easier. So you're valuing your company at 15 million today?
Yes, that's right. Yes, based off of our ask.
Okay, what's the justification for that?
Well, a large part of it is our proprietary technology. We have the highest selectivity and specificity for lactate in comparison to our competitors, and we believe that even if we were to sell the technology itself today, it would be worth that amount.
Do you have any justification? I mean, I would have expected a discounted cash flow against your upcoming revenue to support the existing valuation.
Right. Really, it's based off of, yeah. Sorry, go ahead.
No, just in an era of rising interest rates, you're going to find yourself in a position where a valuation like that is probably a little high and difficult to justify.
Right, and that is something that we are open to negotiating as well. The ask is 5 million at 33, but depending on the investor and what their interests are, we are open to negotiating that as well.
And then, of course, the next question right after that is use of proceeds.
What's that, sorry?
Use of proceeds? Use of
proceeds. I think the last slide spoke to that. We divide into 3 categories: operational costs, marketing, and product development. For operational costs, it would be the medical device laboratory expenses and salary for employees. Marketing would require search engine optimization, webinars, and medical device conference sponsorships. And then product development, that's stage 3. That's the development of the medical device. Currently, we're in stage 3. And then receiving approval from FDA and Health Canada.
And last question, and then I'll turn this to somebody else. How many other funding rounds are you expecting to do before you exit?
Well, I suppose that's really just a moment. Time will tell. After getting the initial seed funding, we'll see how many series we'll need. Perhaps we can stop at just Series A. I think it really just depends on interest from our investors, as well as, our end goal again is acquisition. So if we are approached by Abbott Laboratories or any other competitor of theirs, then we'll be happy to exit earlier as well.
Thank you, Alvin. Thank you, James. There's one pending question in the chat there, Alvin. Can you go over the revenue model again?
The revenue model, yes. So that is the, I can quickly screen share. Sorry, 1 second. Right. So we are expecting the first 3 years to operate at a loss. Again, this is mainly just year 4 is when we'll actually launch the product into Canada, and year 5 is into the States. That's where there's a substantial jump once we enter the US market. And this is based off of patients who would qualify or use our technology. So this includes amateur and professional athletes, those with sepsis, other cardiovascular diseases, and we're being very modest with the projection. The Canadian population is 38 million, US population is 330 million. If we're seeing even just 1% is actually using this technology, and it's a very simple microneedle patch, then we're looking at roughly 38 million in sales. And this is based off of a $15 cost of the actual microneedle, and that includes a pack of 50, each one lasting roughly 14 days. And this is what our competitors in the blood glucose monitor space are charging their customers.
Okay, very good. There is a question or a comment there, but I'm gonna cut it off. You can take that comment for advisement, and we'll have to move on to the next group at this point.
Thank you.
Okay, very well. Are we ready with the with the next group, which will be Sensilac?
Yeah, let me just share my screen. I hope everyone can see my screen.
We can. You may proceed.
Cool, thank you. So for any competition or sport, most recently being the FIFA World Cup, it's quite exhilarating and emotional watching our favorite athletes achieve incredible wins. And for us, that would be Messi finally winning his World Cup. But toning their overall performance for ideal execution without facing any cramps or fatigue is quite difficult without sensors. And these injuries, while it may seem small to us as viewers, it can be extremely life-altering for athletes and sports enthusiasts. Good evening, and thank you for having us. My name is Mayhal, and joined together with me is my colleague Sarah, and we're here to pitch you a commercialization plan for a novel biosensor for detecting lactate in sweat. Our sensor is not only not invasive, has a low limit of detection, but is also significantly less expensive than the current products that are available on the market. Now, majority of high-intensity sports produces a biomolecule known as lactate, which is vital for energy production. However, high levels of lactate in the blood can increase the acidity of the cells, which can be extremely dangerous. Acidic blood basically means that the muscles cannot contract properly. It can result in muscle fatigue, as well as a burning sensation, which a lot of athletes and sports enthusiasts face on a daily basis. And therefore, regular lactate sensing can help with conditioning the overall muscles and improve the performance of the athlete with a guide of their health team. And this presents a growth in the sports industry market. Now, this market was worth about $5.2 billion in 2019 and is estimated to grow to about $8 billion in 2027. With that being said, 35% of that growth alone comes from North America. And more specifically, the lactate meter market is projected to grow at a compound annual growth rate of 8.5% from the year 2023 to 2031. And so novel technologies within this field have the ability to be extremely profitable. But what exactly is the issue with the current solutions that can be found on the market? Well, first of all, they're extremely expensive. Globally established companies such as EKF Diagnostics can charge up to $100 to $400 per test strips. Furthermore, some of their devices, such as their Biosen analyzer, is inconvenient because it's not handheld. Along those lines as well, some of the reagents include the use of enzymes. Plus, they're also sensitive to temperature, humidity, and sunlight. Moreover, they are also meant for use in blood, which is an invasive mode of detection. That being said, there are newly established companies such as PK Vitality or iDro, which looks into non-invasive sensing in the sweat. However, they can also charge up to several €100, which when converted is about hundreds of dollars in USD or CAD. And that's where Senselac comes in. Senselac revolutionizes the field of biosensing for sweat, for lactate in sweat. Our technology basically uses hydrogels and is composed of the aptamer bound to a graphene oxide, which is within the hydrogel matrix. Without the presence of lactate, the fluorescence is quenched, which means that no fluorescence is given off. However, in the presence of lactate, the fluorescence is recovered. And it is this fluorescence that we plan to measure and use against the calibration curve in order for us to detect the analyte's concentration.
Our technology is non-invasive as the medium is sweat and is more affordable, estimating to be around 5 times cheaper than the average lactate sensor test. Furthermore, the recognition element of our technology has a low limit of detection of 0.55 millimole and is convenient for travel. Following the path to market, we plan on using a market to stock approach, which will take approximately 3 years from research to initial release. During the first year, we will partner with University of Waterloo research groups and develop an initial working prototype, followed by a filing of a patent. During the second year, we will focus on regulation and safety testing, which will include requesting a regulatory compliance and medical device establishment license. We also plan to create a startup and look into outsourcing production manufacturing from external companies. Finally, during year 3, we will begin production, marketing, and release of the product. We are expected to spend approximately $800,000 for the commercialization of Senselac products, which is split over 3 years. To begin research, prototyping, and troubleshooting is projected to cost a total of $42,000. Intellectual property filing for a total of $17,000. Commercialization assessments, that includes regulation and safety testing, which is projected to cost a total of $36,000. Building a startup, including equipment and other expenses, for an initial cost of $50,000 and an annual cost of $20,000. And outsourcing production with an annual cost of $600,000 and other expenses such as marketing. According to our research on sports associations that offer medical services to athletes across Canada, the market size is approximately 25,000 athletes. Thus, we can estimate a minimum of 5,000 customers per year, each expected to use approximately 12 patches per year at $50 per unit. Projected profit per year should be approximately $3 million starting year 3, which is expected to grow to $6 million per year by the end of 2031.
And I'm afraid you're at time there, so we'll have to cut you off.
That's okay. I just finished.
There's the team.
Yes. So here's the team.
Thank you very much. Do I have any questions?
Can I jump in, Dave?
Please, John.
Sure. I'm not an athlete, but I'm curious. Just revisit the product market fit for me. Why do I care if my lactose is high? And if I'm an athlete and the patch tells me it's high, what do I do? Does it change my workout, or do I just wait until I'm better? Like, articulate more why this is important and why it's urgent to have real-time information. Why am I paying for this product when I'm not using it now?
So basically, with athletes especially, high lactate, as I mentioned, basically results or is an indication of acidic blood, which basically means that the way that your body is metabolizing or is using lactate is in a way kind of not efficient. So the idea is that, you do your whatever 5 or 10K run, as if you're, for example, a runner, and you would measure your lactate based on that. And the idea is that with their health team, they are able to take that number and, I guess, modify their workout for the future runs in that sense. Now, these patches that we are planning to create are sort of one-time uses, and they're not necessarily something that is continuous. And so because they're not continuous, they are relatively cheap. And so it's meant to do your run, see where you're at, and then, modify your next plan based on that.
So then this is a product for very focused high-end athletes, if not Olympic level athletes, not necessarily for your weekend jogger.
Exactly. And so that is our starting market, would be for athletes. Now, that being said, because it's a one-time use, it can be transferred to other markets. So for example, if you ignore athletes and look into just cancer patients or patients who have metabolism issues, these patches can be used in the hospital or in clinics in order to help diagnostic medical team or doctors diagnose their patient at hand. Now, that is a market that we're not facing currently for our current projection, but that is definitely something that is transferable and can definitely be easily adaptable to based on how we market the product. But the concept and the use would be the same thing.
Okay, thank you.
Yeah.
Any other questions? Hearing none, I will thank the team on their excellent presentation, and we will move on to our two finalists from the University of Guelph. First on the list is Gashin Lee.
All right, everyone. Just waiting for the slides to come up. That's perfect. Okay, we'll get started. So hello, everyone. My name is Usher. I'm here with my partner, Adam, representing Western University. So investors, the future is electric. And with the push from both consumers and governments, electric vehicles will dominate on the road. And we really believe that our new technology, a high-strength, high-conductivity aluminum alloy, will significantly improve the performance of EV and change the EV market forever.
The EV market is growing rapidly with demand from governments and consumers to reduce global carbon emissions. However, the market is not growing fast enough to meet this demand. Compared to conventional gas-powered vehicles, EVs are more expensive to produce and have a poor performance in terms of range due to the overall weight of the vehicle. EVs contain specialized material components like copper for its high conductivity, and due to increasing market demand, prices are rising. Therefore, we have identified a clear market fit for our aluminum alloy as a lighter and cheaper alternative to existing materials. We'll be targeting EV manufacturers with our consulting services to help reduce their production costs and improve the performance of their vehicles by weight reduction. Comparing the cost of copper in both vehicles, globally, EV manufacturers spend $8.6 billion more per year on copper than traditional ICE vehicles. This presents a lucrative opportunity for our aluminum alloy to replace copper.
Yeah, so we want to give a deeper dive into the materials as well as the technology that we're presenting. So aluminum in its purest form is extremely high in conductivity, but it lacks the strength needed to be in certain parts of the vehicle. In its most common form, AL319 on the right side of the graph is much stronger, but lacks the conductivity needed for electrical applications. As Adam has mentioned, copper is used because of its high conductivity, and we see this being represented by the red line on the graph showing the percent conductivity of other materials compared to copper. As it stands, aluminum is not as conductive as copper. However, if you factor in the weight of the material, which is represented by the yellow line, we see that our aluminum alloy is far superior. Battery trays, power supply systems, conductors are all components where this technology has the potential to replace copper. And furthermore, this alloy is castable, making it a versatile and cost-effective material to work with. As well, aluminum is much easier to recycle, with more than 97% of aluminum we ever produce still in circulation today. This will improve the sustainability of our vehicles and truly change the performance of EVs as well. In terms of the business model, as we know that the auto industry is dominated by OEMs and traditional car manufacturers that are some of the largest companies in the world. We believe that these companies are successful and dominant because they have built efficient supply chains and have great expertise in manufacturing. Rather than trying to compete on that front, we want to sell our technology with a higher, rather than competing on that front and selling technology through manufacturing different parts, we want to focus on providing services to help them identify the key components that can be improved. By outsourcing their work to us, they can really enjoy their already efficient supply chain, focus on their own core competencies, and have more flexibility in their design. On top of charging for the consulting service, we'll also be using a licensing and royalty model for our technology. With that, in our first year, Adam and I plan to wrap up market research and start to enter into trade shows, technology forums, or any networking events to help us build relationships with our customers. As well, we'll be hiring engineers, legal staff to finalize technology and submit for patent application. In the second year, we hope to get our patent approved and complete 3 short-term projects and help us refine our business plans and operations. At the same time, we'll continue to hire and train more engineers while starting R&D to further our technology. Our goal is to develop version 3.4 or even more alloys to meet our clients' demands. As well, we want to form at least one long-term partnerships by the end of year 5.
Our consulting service will generate revenue through 3 streams. We'll charge an hourly rate with projects lasting on average 6 months to a year. We expect to double our consulting capacity through hiring more engineers by year 5. Through patenting our technology, we'll be able to earn revenue through licensing component designs that we've created to manufacturers for a fixed rate, and claim a royalty from the sale of components that use our aluminum alloy. Through our background in business and engineering, we can communicate business needs and translate them to technical requirements. To operate this kind of business model, we'll build a team of experts in the area of EV design and material selection, as well as working closely with patent lawyers to draft contracts with clients. This will enable us to effectively bridge any gaps in our own knowledge and leverage a lean organizational structure to provide dedicated service to clients.
Thank you so much for considering the potential of our high conductivity aluminum in revolutionizing the EV industry. We are seeking a $1 million investment for 10% of our business so that we can help reshape the future of vehicles. Thank you so much, everyone, for listening. We're happy to answer any questions or comments. And yeah, feel free to jump in.
Great. Thank you very much. We'll take a question now if anybody has them.
I'll ask this.
Please
yeah,
go ahead, James.
Sorry. I'll ask the same question I asked the other group. Can you justify you're asking for a $10 million valuation? What's your justification?
Absolutely. Adam, if you could go back to the financial model, and I can go on with the explanation. So yeah, I think the $10 million sort of valuation came from our balance sheet, which is saying that by sort of year 2 to 5, we'll be making $1.8 million. So we'll be making $1.8 million by the end of year 2. So on average, we believe that by year 5, we'll be generating $1 million per year in terms of revenue. And we just sort of took that and sort of 10x'd it, and that's kind of how we got to our valuation. And I think over time, we'll be able to see sort of that initial investment sort of improve over time as we sort of expand and build a reputation within the industry. And then we only projected sort of smaller projects that initially, and I think that once we're able to touch sort of like larger projects such as like Tesla, where all these companies will be able to sort of explode in terms of the number of units that we're presenting, and that will really, I think, justify the $1 million investment for 10% of our business and justify that valuation.
Okay.
Yeah, so I see a question in the comment.
Please.
The question is, because this aluminum alloy is still less conductive and more resistant than copper, how much would it heat up during high current applications, and will this impact the strength of the alloy when it heats up? Yeah, I think that's definitely like a valid point. I think in terms of the initial ideas, we just wanted to look at it from a much simpler perspective. So these components will be much lighter than copper, so that's why we want to use it. And in terms of the specifics, I think it will be you'll have to be by designs of different components. We're already seeing this transition from aluminum alloys to copper as it is now, but but obviously more testing or research need to be done in order for us to understand how it reacts to heat. But generally speaking, electric conductivity is sort of increased linearly with thermal conductivity. So I assume that the material should be okay.
Excellent. Thank you, Usher. Any further questions for the team?
I might just jump on James's question for a minute. If you guys can make money consulting, like why on earth are you trying to raise money? Why don't you bootstrap?
Yeah, absolutely. So I think I sort of made a comment later on in our slide, which is that the revenue that we're making in the initial phases are not going to be fully realized until like year 2 or 3. So obviously we'll be making some money through consulting, but I think the business model generally is that the consulting fee will only be so much, and then the royalties and the other fees is really where you generate revenue, and those requires us to do extensive R&D as well as doing different prototyping that will be absorbed into our costs. And of course, the royalty fees won't really be realized until the final sale is being made, and that's why we need the initial investments sort of to back up those initial costs.
Okay,
And the comment that I'll add on that is having founded a successful consulting firm and grown it up to 6 people, it's going to take you a lot longer than 2 years. I think your revenue projection is aggressive.
No, that's totally a fair comment, and definitely we will take that back into consideration for sure.
Excellent, very good. Well, very, very interesting work, and we'll change gears now to the next presenter. And that will be Wonder Metal. Are you ready to proceed?
Just go share my screen.
Excellent, there it is. Please go ahead. Is your co-presenter muted there? Maybe.
Yep.
No,
Can you hear?
Gita, I don't think we can hear you, unfortunately.
Hello. Can
That's
you hear me?
better. There you are.
Okay, perfect.
Okay, please start again from the beginning.
Okay. Sorry about that.
No problem.
Living in Windsor, the automotive capital of Canada, has long inspired my partner, Akshat, and I to improve on the automation sector. And today we are here to do exactly that by introducing the high-strength, high-conductivity aluminum alloy. Battery trays are a vital component in cars. They hold the battery in place and provide power to the electric motor. They are designed to withstand the weight of the battery and vibrations of the vehicle, among many other things. However, these trays are currently manufactured for electric vehicles using conventional aluminum alloys. These alloys are prone to damage and reduce the tray's ability to withstand collision upon impact. They also cannot endure high temperatures, and any welding operation can make it extremely difficult to perform leak tests on these trays. And lastly, their lower heat and electric conductivity limit their application and forces engineers to resort to different materials and different options that weigh and cost more. The high-strength, high-conductivity aluminum alloy presents solutions to all these problems and more. It provides high-strength properties and therefore absorbs more energy in case of a collision, which keeps the battery and its expensive components in good shape. It also provides a good weight-to-strength ratio, which allows for the manufacturing of lighter vehicles. It endures high temperatures and can help save up to 8 minutes per tray on leak tests. And lastly, they provide high electric and conductivity, which can therefore improve the overall power transmission of the car. This alloy offers a variety of unique specifications. It can be hardened using 4 different methods. It can also decrease the weight of a product by its ability to replace a material that weighs heavier. It also reduces manufacturing costs by eliminating the need for extra material and increases recyclability. The technology will first be marketed to hybrid and electric vehicle manufacturers in North America. This includes companies such as Valiant, Linamar, and Magna. This will help us by facilitating the crack into the automotive sector, which is much more complex. And it can also allow us to focus on building relationships with tier 2 and 3 suppliers.
And to add on to that, the opportunity to grow in this business is highly underappreciated, since the global market manufacturing is expected to grow by around $3 billion by the end of 2025. This is largely due to the fact that the Canadian government has imposed regulations stating that the vehicles sold in Canada in 2035 must produce 0 emissions. In order to break into the automotive manufacturing market efficiently, we plan on establishing a non-exclusive license in order to secure the alloy composition for our company and advertise it to our multiple customers. While discussing a licensing agreement with our battery tray manufacturers, we will cover our royalty rate on revenue sales per unit, as well as services such as consultation, maintenance that we can provide. The cost for these services will be dependent on the size of the business. However, we were able to estimate the average cost based on the number of units that the company is manufacturing per year. As a result, the majority of the revenue generated by our team will also be dependent on the scope of the order that we can acquire. By researching the current market data, we were able to determine that the cost to manufacture a battery tray and average selling cost of these batteries to typical economic cars, on average, the manufacturers are generating $500 per battery unit, in which after royalties, Team Wonder is able to take home $40 per unit in exchange for outlining the manufacturing process for the tray, as well as providing the composition for the alloy. We determined an ask of $95,000 to cover our operating expenses, such as patents and testing, as well as non-recurring expenses. Correspondingly, we determined our projected growth for the next 5 years by using a growth rate of 5% and constant increase in the number of total units sold by our customers and the services provided by Team Wonder. Ultimately, our goal is to transform the company that is able to dominate the battery tray industry and expand our efforts into new areas. We can achieve this by focusing entirely on testing and developing our product in the first year to ensure it can be marketed to our customers. Once we have a solid customer base, we would focus on higher tier manufacturers and emphasize on popularizing our brand within the industry. At year 3, we would like to stay current within the new technologies and develop our product further to stay ahead of our competition. Afterwards, we would consider our brand to be profitable enough to employ specialists to help in R&D, consultation, and maintenance. Lastly, we would like to be able to expand further into the ever-growing automotive industry as an established and well-reputed brand. Currently, our team consists of Gita Hamoud and myself, Akshat Kunder, both pursuing a degree in mechanical and aerospace engineering, and we plan on growing our team as we continue to progress. Thank you so much for hearing our pitch. Are there any questions?
There is one in the chat there, if you can read it.
What is the rationale for 7.5% royalty? We wanted to make sure that a percent of that royalty would go towards the patent holders. The technology is not currently patented, but as soon as it will, we want to ensure that the patent holders are getting a percent out of that, and perhaps approximately 5% of the rest would go to actually funding the team and helping grow the funds to recover the ask and reach our goal in 5 years.
You know what the existing margins are on batteries?
For startup companies, that is less than 5%. So our hopes are a little up for the 7.5. The reason being that we are located in Windsor and have been in contact with the companies that we have mentioned prior, for example, Valiant. So we do know their willingness and their openness to actually accepting new technology, especially for battery trays and not just the entire vehicle itself.
Sorry, let me try that again. What's the existing margins on a battery tray that from another competitor?
So currently, for example, if a battery tray were to be manufactured, were to be defaulted and have to be manufactured, they would charge the customer around, for example, Tesla would charge $16,000 for a Model 3. However, we wouldn't be charging that 7.5% on the 16,000. We would be charging on the margin that they are making, which is approximately 70%.
Okay, so now we're going into two different questions. One, I would suggest that you want top line, not bottom line, because somebody can always play with the numbers in between. So you're going to want it off the actual sale price to the consumer. But
Okay.
where I was going was trying to understand what the existing margin is on an existing battery tray to understand where you're going to take, whose pocket you're taking the 7.5% out of.
It would be the companies that we are marketing to. So for example, the battery trays manufacturers that we had previously mentioned, those we would be charging those companies 7.5%. Some of that royalty fee would go towards the patent holders and the rest would go to us. The reason we are doing that is because an extra percent is then charged to the companies that they are selling to. So for example, Valiant supports Ford. They would charge Ford a markup before they sell it, but we would be targeting Valiant, so we would be charging them the 7.5%.
Okay.
Thank you. There is a question in the chat there relative to aerospace grade aluminums, if you can see that.
The reason you wouldn't want to use aluminum that is currently being used in the aerospace industry is because it could potentially cost more. Part of engineering is allocating your resource properly, and even if you have a material that can handle double the stress and double the strain, that might not be the best option to go for. Thank you.
Thank you very much. Any further questions? So hearing none, I'll bring this round one to a close. I thank all of the participants very much for your hard work and for your pitches, and we'll allow the judges to go and deliberate while we listen to a keynote speaker, Jeff Van Humen, Director of Business Development from Ontario Centres for Innovation. Thank you, Jeff.
Terrific. Thank you, Dave. It's a pleasure to be here. Let me just see if I can share my screen. And why am I not seeing what I'm looking for here? Apologies, I'm going to stop sharing that. And one moment, please. I apologize for the technical challenges. Oh no. Can you hear me?
Yes, we can hear you.
Okay, why can't, there we are. Okay. Apologies that I've been, there we are. Apologies for that. And I'm just going to, hopefully you can see that now.
Yes, we can, Jeff. Thank you.
Okay, and again, apologies for the mess up there. So just want to thank the organizers for the opportunity to speak with you today. I also want to provide regrets on behalf of our CEO, Claudia Kreviak, who unfortunately couldn't join us today. It's the end of our fiscal period, and there's a very large board meeting that's going on right now. I also wanted to thank my colleague Belinda Ray for stepping up to judge today, this afternoon, and help with the Proteus competition. Hard to believe that it's been 8 years since the competition began. So just to kick things off, for those in terms of the agenda, I'm just going to give a little brief overview in terms of who is OCI. If you don't know Ontario Centre of Innovation, I'm going to give you a brief overview of that. Then I'm going to talk about why we're here in terms of innovation, talk a little bit about collaborations, share some interesting data that we have. I'm not going to go into intellectual property a great deal. I'm going to leave that for Jeffrey North, who's going to be talking a little bit later. And then I'm going to end with a little bit of maybe a couple of opportunities that you might want to consider as you think about whether you're going to proceed with commercializing the technology that you've been working on recently. So just in terms of who we are. So OCI, Ontario Centre of Innovation, is a not-for-profit organization that provides funding to Ontario-based SMEs, startups, scale-ups, multinationals to support their innovation agenda. We've been around for 35 years, and we gain most of our funding from the Ministry of Economic Development, Job Creation and Trade, as well as other ministries in the province and the federal government. What's interesting is that, and I'm going to share just a small bit of this information a little bit later, but we have been supporting projects all over the province of Ontario. And you can see, and at the last count, I think we've touched on 180 communities in the province of Ontario, and it grows every day in terms of projects and where we support them. In terms of our program portfolio, and it's interesting hearing the pitches that were earlier today, we cover a lot of the territory that those pitches are within. So in terms of our Collaborate to Commercialize program, we're going to talk a little bit about that in a moment here. That's around technology development and commercialization. We also work in the area of life sciences specifically, and non-life science investments around our ready for market. I'm going to talk about those two things very late in the presentation. One of our areas that we look from technology to adoption is our Ontario Vehicle Innovation Network that supports technology adoption in connected, autonomous, shared, and electric vehicle technology. And finally, most recently, trying to support digital adoption in those areas that there needs to be more technology or digital adoption. Moving on then, I can't, as I support the business development network within the province of Ontario, I can't have a presentation and not talk about the team that I support. So we have business developers strategically located across the province of Ontario. These are domain expert professionals that are supporting collaborations, connections, and also being a convener within the communities that they serve. So, getting into the meat of our discussion here, I'm going to talk a little bit, and this is by no means a fulsome conversation, but I do want to share a little bit about innovation. And I think I'm talking to the converted here. Why do we innovate? And you can see in each one of those pitches that is at the core of what you're trying to do. You're trying to gain a competitive advantage. You're trying to, within your organization that you're trying to create a culture of agility and creativity. While at the same time supporting a lean organization that is being prepared for growth. At the beginning of that exercise, though, in terms of innovation, you have the light bulb moment. You have the idea. What are we going to do here? And you want to actually develop some technology, and you ultimately want to commercialize that for the benefits that I just stated. However, you're looking at your own organization, you're considering the resources that you have, both human, financial, and potentially infrastructure, and you're thinking, how am I going to do this with what I have? And at that moment, you think about collaboration. And if my slide will advance, there we are. And that's where we are all here today, is in terms of collaboration. Why did you all come together to identify technologies in various institutions and build strong teams in order to allow for potential commercialization of that technology? And so within Ontario, of course, we have partners at the university, colleges, or research hospital that we could collaborate with. We want to consider those partners while we are looking for and determining what might be a project scope, the collaboration partner role, as well as our role in that collaboration. And we also want to, at the same time, anticipate the outcomes from that work. What might be the intellectual property that's being created, what would be the commercialization plan, and of course, all of the relevant business associated activities that would be part of that. And then finally, we also want at the same time to leverage the community. And I don't necessarily mean the academic community. That can be the regional innovation centers. I noted that Christine is here from Tech Alliance. It could be funding partners like Ontario Centre of Innovation, MyTax, IRAP, for example. We want to take advice from all those things before we pull the trigger on collaboration. So what I'm really excited about here is this. I'm going to share a few tidbits of information that we have amongst a vast array of data that we have associated with collaborations, and some of them that have generated really interesting results. So this is a collaboration with Western University and A&L Biologicals. A&L's here located here in London, and collaborated with Dr. Greg Thorne, associated with investigating crop yield variations beyond soil nutrient levels and considering soil microbial communities. The technology that came out of that has actually generated a new service revenue stream for A&L called Vitalis Bio, a very exciting new opportunity. At the University of Windsor, another company, Terrasano, collaborated with Dr. John Trent in order to look at development of soluble ozone as an antimicrobial agent. That provided an opportunity for Terrasano to actually engage with 5 new customers and maintain 12 create 12 new positions in their organization. In Hamilton with McMaster University, they partnered with, Triumvira partnered with Dr. Jonathan Bramson in order to develop a new class of therapeutics to enhance patients' immune systems in order to treat B-cell lymphoma. What's exciting here is not only did they create 25 new jobs, they had follow-on investment of $43 million, a significant opportunity through these collaborations. Finally, I'm going to share this information with regard to a company that I have a whole lot of respect for. This is Genesis Bioindustries. If you're not following them today, you should be. They had a collaboration with the University of Guelph with Dr. Deeb, and where they were looking at a detailed material characterization of Genesis PHA polymer. Genesis is a forerunner in the technology associated with developing PHA from food waste, and in fact are doing some incredible work. They've partnered with the University of Guelph, but also with the University of Toronto and Lambton College, and are most recently the Amazon Climate Pledge Fund recipients, one of the foremost opportunities in this area as well. So they're doing, tremendous work in commercializing the technology that's coming through these collaborations. Finally, just one last comment on the University of Waterloo and a well-known community member there, ClearPath Robotics, that collaborated with Stephen Wolfsander, and the work that they did in terms of looking at autonomous robot technologies and collision avoidance, and the incremental sales that were generated from that. What you can see from this process of outcomes of innovation is that you have superior capabilities within Ontario colleges, research hospitals, as well as you can see that the benefit of this type of collaboration benefits all types of companies. Broadly speaking, you need to consider who is the right collaborator for you. Recognize that might not necessarily the one that's located closest to you. Any industry sector can benefit from it. And as you can see, some of the successful outcomes are employment opportunities, revenue, and competitiveness. I know I'm just about at time here. I'm not going to take too much of the message that Jeffrey's going to leave with us later in this evening. But one outcome of any innovation collaboration process is intellectual property. Be thoughtful about your IP strategy and recognize that it might not necessarily be the obvious one of patenting. And finally, I just want to leave you with the idea that IP policy differs by institution. Finally, two identified opportunities for you. The life science opportunities that were discussed today, they might, when they're ready for investment, please reach out. There's a life science investment fund where we will co-invest up to $500,000 of matching investment of early stage health tech, life science technology. And for non-life science, and this is where Proteus is particularly good at identifying these opportunities. For those technologies that are commercializing academic IP, we have our ready for market opportunity that can invest up to $250,000 to match a private sector co-investment. And at that point, I will say thank you very much.
Thank you, Jeff, so much. That was an excellent presentation and a great overview of where you've been involved with university to commercialization outcomes. You and OCI are a great partner to startup companies, university-led innovations in the area. So thank you. We're now at a intermission to allow our judges to deliberate. We'll take exactly 5 minutes. I have 5:18, so we'll come back at 5:23. We'll see you shortly. Okay, welcome back, everyone. We will get started with our second round of pitches. And for that, I'd like to introduce a new panel of judges. Belinda Ray from the Ontario Centers for Innovation, OCI, Rami Alhamad from Invest Ottawa, and Adam Power from Western University. Thank you very much for your time and for your attention. And our first teams will be finalists with University of Windsor. And we will start with Lion Textiles. If you're ready to go, you may proceed.
Just waiting for the PowerPoint. Almost there.
Can you guys see the screen?
Yes, we can.
Perfect.
All right, let's get started then. Hi everyone, we're Lion Textiles, and today we want to share with you a commercialization plan for our technology, e-textiles with lithium-ion batteries for neonatal monitoring. So it might be hard to believe, but within this mass of wires and tubings is an infant. He's one of 15 million that are born preterm every year, and that's more than 1 in 10 babies born who need round-the-clock care monitoring in neonatal intensive care units or NICUs due to their underdeveloped organs, hence the mass of wires. So unfortunately, these wires, while they're life-saving and vital to neonate survival, they also have their downsides. So the number of monitors make it very difficult to move the neonate around, and it's challenging for parents who want to hold their child and have that parental bonding. And more importantly, the medical adhesives used to affix these wires and sensors can be damaging to a neonate's delicate skin. And there's been a study that has shown that 34% of patients have experienced these skin injuries. And as a result, any solution that can decrease the tangle of wires while maintaining enough contact to the infant to continue this accurate vital tracking while preventing the use of medical adhesives would be a game changer.
A technology where an infant doesn't need to wear wires could solve this problem. For example, an outfit that is worn by the neonate that is equipped with all of the sensors required to detect the necessary biometric data. However, black box battery packs, which are typically used to power wearable electronic devices, are not suitable for this situation given their bulkiness and their heaviness. This is why Lion Textiles has developed a fabric integrated with a lithium-ion battery electrode that is lightweight, stretchable, and protected from mechanical strain, which can be used to power sensors on clothing for neonates. The fabric consists of 2 parts, a warp-knitted framework of yarns, or the bridges, and a cut pile of fibers, or the islands. The electroactive materials are deposited on these islands. When the fabric is stretched, the bridges elongate, but the islands remain in place, which protects the brittle electroactive materials from mechanical strain. In comparison to the current standard, Lion's technology can result in decreased injuries as it does not use medical adhesives. And this also lowers the risk of infection. It also encourages parental bonding since the infant isn't immobilized by wires. It's also easier to monitor infants from home, freeing up hospital space and nurse time to care for other patients.
However, there are 5 key steps that must be completed before this device is used in hospitals. Initial research and development, or R&D, is expected to cost $250,000, according to previous e-textile research efforts. The patent costs, including additional U.S. provisional and national filings, are expected to reach approximately $8,000. Clinical trials and Class 2 medical device FDA clearance will occur with the support of a licensing partner, which is expected to cost approximately $3 million in total. One of the most prominent assets that will be used to start the Lion Textiles company is the patent on the stretchable and wearable electrodes. This patent is currently filed in both Canada and the US, and from initial R&D results, an additional US provisional, then PCT, and national patent filings will need to be incorporated into the next steps, and R&D as soon as there's proof of concept. Based on a 3-year timeline, initial R&D would include the application of the lithium-ion battery interwoven in textiles that are safe for neonates, such as knitwear single cotton or knitwear polyester interlock, and the Lion company can officially launch. R&D would also include the strategizing of manufacturing of the technology, ideally in a solution based for scalability, washability, and battery optimization. A portion of this cost would also be covered by the Natural Sciences and Engineering Research Council of Canada, or NSERC, and once promising initial results are gathered, a business accelerator support, such as the one in Innovations Factory Sophie grant, can be used to fund the ongoing R&D and additional patents. Their support will also be used to determine potential market capture, given that the global market size for neonatal care equipment is currently $1.93 billion USD. The business accelerator will also help in connecting additional licensing partners that have experience in the biosensor space, such as Abbott Laboratories. And after an agreement is made, secondary development of the technology would occur to incorporate biosensors into the actual textiles. And after clinical trials and FDA clearance, L-ion textiles can also be free to explore other potential applications of the lithium-ion batteries in textiles for industries such as fashion or health and wellness. These steps will be carried out by our team, which comprises of experienced professionals who have successfully created multiple commercialization plans for various biotechnology. And based on the potential of this company, we're asking for $250,000 in our first round of seed funding to cover initial R&D, market research, and intellectual property costs. With your support, L-ion Technologies will hope to support patients and children alike by detangling these vulnerable infants. Thank you for your attention.
Excellent job. Thank you very much. Good presentation. I'll open the floor for questions now if anybody has them. Any in the chat? Any from our judges?
I have a question around the costs that are quoted. So for the initial prototype development, are you working with Canadian suppliers, or is this just like in-house costs for materials and like in-house fabrications, or do you mind elaborating on that?
For sure. So currently we are just using in a smaller scale to build prototypes. That is going to be specifically any in-house or smaller laboratories that are or where the manufacturing is done in Canada. But as we grow, we're thinking of scaling the manufacturing, which will be possible with a solution-based manufacturing strategy. And that would likely occur somewhere in the North America. For example, I know Starfish Medical is a potential manufacturing company that we can partner with, and they do lots of large-scale manufacturing.
Okay, thank you. It was a very exciting idea. Thanks.
Thank you. And Belinda, I think you had a question as well.
Yes, I did. Thank you, David. Yes, sorry, my name appears as Jeff's, unfortunately. But thank you for your excellent presentation. I just wanted to get a better understanding of the competitive analysis. I mean, you obviously, your first slide showed sort of the current state with wires and so on. Are there any other companies that you're aware of that might be doing something similar?
Absolutely. We actually have additional slides on this as well, I think.
As for additional companies, there are no startups that we are aware of. However, there are other research labs that are investigating other possible lithium-ion battery electrodes that can be integrated with textiles. So essentially a similar idea. These include carbon nanotubule fiber-based lithium-ion battery electrodes. Essentially, instead of integrating it directly into the textile, such as what L-ion Textiles does, they essentially have created a carbon nanotubule that serves as the electrode, which is then woven into the strands of the yarn. And so these are some of like the other similar competitors that are currently in R&D.
Thank you.
Any other questions from the judges? Any questions from the audience? Very good. Well, with that, I will wrap up this presentation, and we will move on to the next group. Vitalian Technologies. Are we ready to proceed?
We should be here. Let's see. Awesome. Can you guys hear us?
We can. We can see your screen as well, so please go ahead.
All right, we'll get started in a second here. Okay. This is John. John is a factory worker who works hard to support his family. Last week, John was fatigued at work and unfortunately fell and broke his leg. John is no longer able to work, and now his employer has lost a valuable team member. Situations like John's are not uncommon and often come with catastrophic consequences.
Industrial workers are not safe. 153 workers are injured every minute, and fatigue is a primary factor. Injury-related costs are $153.4 billion a year in the USA alone. And despite health and safety budgets increasing to $1,300 per worker, preventable deaths are rising. This shows that the demand is there, but the current solutions are not working. Workers need to be notified of fatigue and be respected and protected. Our solution begins with a physical product, a t-shirt that tracks biometric indicators. This data is then analyzed using a machine learning algorithm that quantifies the level of fatigue. Employees are able to view their real-time fatigue levels on our mobile app. This data is kept private from the employer. If an employee reaches a dangerous level of fatigue, they will receive an alert. The employee then has the option to share this alert with management or not.
So we designed the Safe Tee. Using Dr. Carmichael's technology, we can create a shirt that acts as a lithium-ion battery electrode that is stretchable, wearable, and washable. Now, this shirt will power the biometric sensors that we integrate in the shirt in order to read heart rate and its variability, respiratory rate, energy expenditure, and galvanic skin response to stress in order to identify and mitigate fatigue injuries.
Our software is a combination of a mobile app and a web app that workplaces use to identify employees that have reached a dangerous level of fatigue. Only individual employees are alerted when they reach the threshold. They then have the option to share with management for the betterment of the company. Conversations with engineer Alex Kopach indicate that this software will cost approximately $100,000 and take 6 months to develop.
From a competitive standpoint, we're the first to integrate this technology into the market. There is no other direct competitors that use real-time monitoring in a device that is suitable for industry and has an injury prevention alert system in order to reduce these fatigue injuries. We also penetrate the market at the low price of $75, which is lower than our direct competitors.
We will be targeting the average manufacturing company. They have 250 workers and a $326,000 budget for employee wellness. Management wants to reduce the risk of injury and death while increasing their bottom line, while workers want to feel safer and valued while staying comfortable and independent. The market for wearable technology is massive and growing. In Canada and the USA, it is valued at $66 billion. The market is expected to grow 400% by 2026, with the industrial share expected to double in the same time period. Adoption is increasing, with companies such as Amazon implementing similar technologies in their warehouses. We face standard regulatory barriers, such as consent forms, cybersecurity, and privacy standards.
Now let's take a look at our business model. The first step is outreach, where we consult prospective customers to see what they need. We then place a custom order with our manufacturer in China, and the manufacturer will ship the shirts to our location in London, Ontario. We will then distribute the shirts ourselves, and this allows us to set up the product with the customer and troubleshoot any concerns that they may have. Our sales package includes both a physical product and a service. The shirt will retail for $75, is offered in a full-size run, and we recommend that an employee has 5 shirts, one for each day of the week. The software solution is a centralized app with fatigue detection software and a notification system to alert employees when they're at risk of a fatigue injury. Working with Alex to design the software, we've also ensured that it is both HIPAA and PIPEDA compliant to operate in Canada and the United States. But why does the business work? Well, if we were to sell to the average industrial manufacturer, we would generate almost $94,000 in revenue and approximately $58,000 in profit. But it's even better from the employer side. For every dollar invested in employee well-being, there's a $1.46 return on investment, bringing the economic value of their purchase to just over $135,000. The economic savings of reduced workplace injury due to fatigue is just over $43,000 because of this.
We are the right team for this challenge. Colby and I have experience across various industries, including industrial manufacturing. Our advisor, Alex, is also an entrepreneur in the life sciences space. We are excited and capable to take on this industry.
Thank you very much for your time. Do you have any questions for us?
If you don't mind going back to the competition slide, it's a very exciting product, and it's near and dear to my heart. I've spent a lot of time with smart textiles. Do you mind kind of walking me through your thinking around why is your product more suitable for industry than a Fitbit Charge or Polar H9?
Yeah, I'll take this one. That's a great question. So in regards to something like a Fitbit, obviously you wear the Fitbit on your wrist. If you're working in a factory where you're doing hands-on labor, you're working in a coal mine, situations like that, the Fitbit is at risk of getting damaged, broken, or lost. And there's also the adherence component where employees would have to put that on every day, and some employees may forget or choose not to. Hopefully everybody puts a shirt on every day to go to work. And then on the other hand, the Fitbit is also more expensive than the shirt, which just means that it costs the employer more to replace it.
Yeah, it'd be helpful to kind of get a sense of the cost breakdown a little bit more as well. How do you plan to make these shirts for $75? I'm assuming that's retail, right?
Yeah, absolutely. That's retail. So in our business plan, we actually have a variable cost schedule. And this includes, obviously the material for the shirt, the electrode plating, and then we also included things like shipping, the charger that we're going to bring with the shirt so that the employees can charge the shirt, royalties, duties, and then also the commission to Dr. Carmichael, which is the 5% royalty that she mentioned.
Okay. Yeah.
So if I jump in, having done business in China, how do you plan to protect your IP at the point that you're doing the manufacturing and it's only going to cost you $100,000 to build the software? What's to stop somebody from running a factory across the street and taking over your business?
Let me take that.
What was the question again? Could you repeat that, please?
You're planning on doing the manufacturing of the shirts in China?
Yes.
Okay. So at the point that you're doing that, and it only costs you $100,000 to get your software platform off the ground, what's to stop the factory from starting up across the street and running the business at a much lower cost than you? How are you protecting your IP?
How are we protecting our IP? So part of that is the product or the technology is developed by Dr. Tricia Carmichael out of the University of Windsor. So the plan is basically her whole idea was that she does the intellectual property. She takes care of all the research and development. We are just sort of the marketing team that's bringing this into the industry. And we're paying her a 5% royalty in exchange for that. So we would work with her on that to help her along that process.
So, I mean, a suggestion, figure out what's core about that IP and develop it outside of China.
Okay.
Just be real careful about sending all of the details of the technology offshore.
Noted. Thank you.
Thank you for that.
Any further questions?
Yes, Dave, if I could just ask one quick question. Could you please, a great presentation, both of you. Could you please go back to the slide that shows the vital signs or what's being collected in terms of the biometric data?
This one here?
Yes. Okay. Does this take into consideration any existing health issues that somebody may have, an employee may have? Have you factored that in? I mean, it's heart rate, but are there other sort of health issues or areas that might not be captured through the software?
Go ahead. I can answer this question. That's a great question. So I think the key to this answer is that it's based on our software solution. So working with Alex, neither Jake or I are specialists with software engineering. So that's why we consulted an expert. And when speaking to Alex, we talked about the machine learning algorithm. So using artificial intelligence to gather the baseline data, and we're essentially detecting variability from the baseline. So, it's not necessarily a standard rate, as every person is different. Everybody has a different resting heart rate and so on. So it's rather, the machine learning algorithm looks at what you do in a typical day and then identifies situations that are completely abnormal. So taking into consideration, prior health conditions, that would be included in your baseline data, and then the variance would go from there.
Okay, thank you.
In addition to that too, this type of technology has been used to imitate fatigue. So there was a previous study out of Columbia University, and this basically compared biometric data scores similar to the ones we're tracking with survey responses, and they found that it was an effective measurement. So For that reason too, we're confident that it'd be a good indicator, regardless of someone's health condition.
Thank you. We have time for one more with Adam.
Thanks, Dave. Hi, everyone. Coming at you live from Victoria Hospital. Great presentation. Thank you for that. Just a simple but maybe more difficult question. Fitbits and those types of things are obviously more durable than t-shirts. So ultimately, in the end, after a year or two, it might end up costing you more using these t-shirts. Do you have any idea how long one of these t-shirts would last, or what are you projecting? Thanks again.
Thank you for the question. So as far as the t-shirt goes, the battery life itself lasts 300 cycles. And that's just the information that we've been given about the product being tested so far. And as for the t-shirt itself, it's a compression t-shirt. So it's something they would wear under their clothes in order to reduce the exposure risk to machinery, sharp objects, doesn't get caught on anything, it doesn't get torn. As far as predicting how long the t-shirt would last in various industries, I think it would depend on which industrial manufacturers we're selling to. And I think that's a problem that we'd have to tackle as we start to generate some sales and get some feedback from our customers.
Thank you very much. Thank you for your presentation. And with that, we'll move on to the next technology from McMaster University. And our first team on this technology is Solar Medical Solutions. Are you ready?
Yes, we are ready. We're just getting our slides up.
Excellent. Very good. We can see your slides and we can hear you, so please proceed.
Perfect. Anna sat in her chair at the doctor's office, shocked with the news she had just received. In the past year, she has been experiencing extreme fatigue, depression, and muscle pain. After visiting her doctor, Anna thought she would be diagnosed with lupus or another autoimmune disease, but instead, she was diagnosed with vitamin D deficiency. Anna is not alone. 1 billion people worldwide have vitamin D deficiency, which is extremely low levels of vitamin D. And in fact, 2 out of every 3 Canadians are vitamin D insufficient. Prolonged vitamin D deficiency can lead to poor health outcomes, such as a weakened immune system and brittle bones. It has also been linked to diabetes and even cancer. As such, early detection is key to reduce hospitalizations and to allow for early treatment options. Currently, different vitamin D testing methods exist on the market. Immunoassay has been the standard test method for many years, but it has several limitations. The method is 18% less accurate than others, which can lead to incorrect diagnoses. Liquid chromatography, or LC-MS, has since become the new gold standard. However, it is very expensive, making it challenging for many healthcare providers to implement. A new technique, direct injection mass spectrometry, or DIMS, emerged onto the market through research led by McMaster University. It offers a greater accuracy than immunoassay while being significantly cheaper than LC-MS. As an efficient and streamlined testing process, with the entire sample preparation and analysis process taking roughly 63 minutes, which saves time and resources for both healthcare providers and patients. DIMS is a validated method that is protected as intellectual property with a patent cooperation treaty. It measures vitamin D levels from a patient's blood sample. Samples are prepared and then directly injected into a mass spectrometer for analysis, bypassing separation equipment. With its increased accuracy, high sensitivity, fast workflow, and cost effectiveness, physicians can receive reliable data quickly at a fraction of the cost of other methods.
Working with lead researcher Dr. Brits McKibben, our team Solar Medical Solutions has developed a commercialization strategy to take DIMS to market. One of Canada's largest laboratories is Dynacare, with direct compatibility access for DIMS to its existing mass spectrometers. Each vitamin D test in Dynacare costs $35, both provincially reimbursed and out of pocket. With McMaster University's strong reputation, partnering with Dynacare is most strategic, as DIMS will service the Greater Toronto-Hamilton area with a revenue of approximately $3 million. And expanding the use of DIMS to Ontario and the rest of Canada will yield a total market value of $17.6 million per year. Part of the exclusive licensing deal between McMaster University and Dynacare is that Dynacare will fully shoulder the cost of the clinical trials and provide 10% royalty rate of the profits. This includes raw materials and lost productivity costs associated with providing services free of charge to patients participating in the clinical trials. In year 1 and 2, Dynacare will hold responsibility for conducting clinical trials through its laboratories and patient pool. This is to fully detect the performance of DIMS in comparison with Dynacare's current immunoassay and LCMS methods. The patent cooperation treaty application that was filed would then be converted to US and Canadian patents by year 2. And by year 3, DIMS will be launched across Dynacare centers in the Greater Toronto Hamilton area. DIMS will further expand to Ontario in year 4 and to all Dynacare centers across Canada in year 5. And if looking to extend DIMS's reach to other countries, entering the US market through LabCorp by year 7 is the most feasible route since LabCorp owns Dynacare. Based on our financial analysis, this partnership is projected to generate $2.32 million in profit over 10 years. Overall, we're asking for $450,000 to cover upfront licensing fees, development and patent costs, and a 10% royalty rate annually over 8 years in exchange for an exclusive licensing agreement between McMaster University and Dynacare. We truly believe DIMS can have a profound impact in vitamin D testing. Together, we can bring a brighter future for everyone, including me and you, and patients like Anna. Thank you. We now open the floor to any questions.
Excellent job, Team Solar Medical Solutions. Questions?
Yes, Dave, I have a question. Thank you, team. That was really well done. Could you please go back to the slide where you're doing the competitive analysis? So just so I understand, the 60-minute, the difference between the immunoassay and the DIMS is shorter turnaround time. And then is that 26% more accurate? Is that compared to the LCMS?
That is compared. Yeah, of course. Thank you so much for your question. The 26% more accurate is compared to the traditional immunoassay method. In fact, through the research led by Dr. Brits McKibben, they compared it to immunoassay methods, and that's the percentages that they found. The difference between the immunoassay method and DIMS, in fact, less people were diagnosed as vitamin D deficient in immunoassay rather than using DIMS.
Okay, thank you.
Sorry if you touched on this already, but I am curious, is this expandable across other types of biomarkers or vitamins within the body, or is it specifically focused on vitamin D? Sorry if I missed it earlier. Just want to make that clear.
Yep, no worries. So this method was specifically developed for vitamin D testing for DIMS, but in the future, there are research opportunities to use this DIMS strategy for other biomarkers.
Actually, I do have another question for the team. I mean, it's wonderful that you have a strategic partnership with Dynacare. I'm just curious how long it took to secure that partnership.
I can answer that question. That's a great question. So with Dynacare, so what we wanted to explore with Dynacare is that we will have the clinical trials will be shouldered by Dynacare within 2 years, and after that we will explore like a permanent relationship with Dynacare within 7 years. Then after that, we can negotiate with LabCorp, which is the owner of Dynacare as well, to further expand to the US. So it's so we wanted to have like exclusive licensing partnership with Dynacare because Dynacare is the biggest laboratory here in Canada with 16% market share, and that attracted us for them to become our partner with regards to our partnership with Dynacare.
Great, thank you.
Thank you so much.
Any further questions from our judges, from the audience? Not hearing any. I'll thank the team very much for their hard work and their presentation, and we'll move to the next presenters. And that will be Vitagen. Very good. We can see your presentation. If you're ready, you can go ahead.
All right. My name is Shiraz Nawaz, and I'm representing Vitagen. And today I'll be proposing my commercialization plan on a novel method for vitamin D screening called direct infusion tandem mass spectrometry, or DIMS for short. Growing up and having our parents always tell us to go outside and get some sunshine or vitamin D didn't seem to hold much meaning at the time. But after staying in all day through COVID-19, we realized that being outdoors builds healthy bodies in more ways than just exercise. And one way is through vitamin D. With that being said, vitamin D deficiency can lead to bone density issues, worsen immune strength, and lead to cardiac or neurological problems. Even in developed nations, vitamin D deficiency is very common. 37% of Canadians are deficient. In America, 24% are deficient, and in Europe, a vast 40% are deficient. Now, there are other incentives into entering this market on top of severity and the commonality of it. In 2022, the global vitamin D testing market was valued at around 700 million and is projected to increase to approximately 1.1 billion by 2030 at a compound annual growth rate of 5.7%. Currently, the gold standard of vitamin D screening is called liquid chromatography tandem mass spectrometry, or LCMS for short, and is offered by companies like Agilent Technologies. The thing is, LCMS, as well as the alternative, protein binding assays, have shortcomings in speed, accuracy, reproducibility, and applications for large-scale use, which are all things that can be improved and actually should be improved on. Now, the Brits McKibben Lab's DIMS provides a more accurate and reproducible screening of vitamin D than the other standards through its 3 stages of separation. This technology is time efficient, taking 3 minutes per sample versus LCMS's 10 to 12 minutes per sample. And furthermore, this method incorporates more automation with a comparable cost to LCMS. When we take a look at the main competitors together, we can see that DIMS is superior, having multiple competitive advantages over the other technology. To summarize, we provide a method of vitamin D screening that is faster, more accurate, efficient, and reproducible, improves screening for large-scale research, and reduces the misclassification of vitamin D deficiency. Now, as for a potential commercialization pathway, the first milestone in this plan would be to license the technology from McMaster, obtain pre-seed funding, and adapt the technology for clinical studies. The next milestone would be to obtain seed funding and apply to the FDA approval process. Because this is a Class 2 medical device, it would require the 510(k) process, in which clinical trials can cost up to $1 million. Third milestone would be to move into the national phase of the patent. I propose filing in Canada, USA, and Europe, which are the largest target markets and would cost around $30,000. Next, the FDA approval, national phase, and certification for clinical use can all be leveraged into an exclusive licensing deal with Diasorin, which is a large international pharmaceutical company. Finally, the next milestone would be to gain an EMA approval if success is seen in North America. Having an FDA approval and a partnership with a large European pharma company makes this process quite easy. As for this pre-seed funding, raising around $500,000 via safe notes would assist in financing the operating and research costs, in which a 20% discount, also uncapped, could incentivize pre-seed VC firms. An example of an applicable VC firm is Front Row Ventures, who is experienced in startups that stem from university-based research and has experience in healthcare and medical technology IP. As for the seed funding, you would likely need to raise up to $1 million to cover the costs of the clinical trials. An example of potential seed funding could be the McMaster Seed Fund. Now, Diasorin would be a good partner as they are involved in vitamin D screening technology and is currently partnered with Sick Kids Hospital, allowing us easier entry into that specific market if a partnership is formed. We would ask for a licensing fee of $500,000 and a royalty of 7.5%, which are standards for this medical technology. As for our business model, our target markets would be large research organizations that conduct research on vitamin D-related illnesses, as well as hospitals and healthcare institutions. Manufacturing and selling the technology, as well as processing sent-in blood samples, like from a clinic, would be our primary revenue streams. Now, the potential revenues can be estimated from the current costs of LCMS technology. The average price for running the sample is around $100, which would net us a $7.5 royalty, and the itself is around $200,000, which would net us a $15,000 royalty for its sale and subsequent $7.5 royalty per sample. This total commercialization plan can be put into action by a team consisting of myself with the Milo office and the Brits McKibben lab as advisors. This incorporates skills both related to business and the biomedical sciences. In entering that pre-seed round to cover initial operational and research costs, Vitagen is asking for $75,000 by the SAFE vehicle. That brings me to the end of my pitch, and I thank you for listening.
Thank you very much, Team Vitagen. Very, very interesting presentation. I will open the floor to questions at this point.
I have a question. Thanks, that's a great presentation. If you can just go back to, reverse back to the use of funds a little bit further. Right there, if sorry, all your funding options. And then just the previous slide, if you don't mind. So yeah, I was just asking about, so your sort of seed funding 510K, and then if you advance forward, you're asking for $1 million, or 500. The total seed funding $1 million. I'm just, if you can just dig into that a little bit more, because that would be bootstrapping to the extreme if you could get a 510K. Through the FDA for $1 million. Can you tell us how you'll be able to do that?
I don't know if it will be bootstrapping. Usually when it comes to a class 2 medical technology, when we go through the 510K, depending on the size of the clinical studies, it could cost up to 1 million. So we would generate this 1 million through various seed funding to generate that 1 million to do the clinical trials to obtain the 510K.
So do you think it's going to cost $1 million? Because I have gone through the 510K process with a medical device, and it was not $1 million. It was a lot more than that.
I mean, it does depend on the scale of the research that we're going through. Based on the article that the technology from Brits McKibben, when they did their research onto their technology, the sample size, the amount of individuals that they were conducting their research on was relatively small. So based on that, I extrapolated up to 1 million. I wouldn't assume it might not be as big as the research that you're alluding to, but yeah, based on this, 1 million was the value I came up with based on the size of a the clinical trial. It wouldn't be as much as something like a drug, but as for a medical device, I came to the conclusion that 1 million would have been a reasonable cost.
Okay. Yeah, I mean, I think if you leverage some of your existing partnerships with sick kids and those types of things, you might be able to do it. But
yeah, I also want to add that even our exclusive licensing with Diasorin, we plan on them shouldering some of that financial burden for the clinical trials.
Just to ask a question on top of Adam's, because I have also taken a device through a 510K. How much development needs to be done on the device is left to go? Is that your total seed funding? Is that $1 million for your clinicals, or is that $1 million for development as well as those clinicals?
That's a good question. So most of the pre-seed funding would go towards development. There is some development left. For example, one of the main things that was noted by Dr. Brits McKibben was that the technology had to be adapted to be able to be used effectively in a clinical setting. So that is the majority of the research that still had to be done. And we plan on using the pre-seed funding for that. Obviously, if there's excess from the seed funding, that could go towards it, but that is the majority of the research that has to be done before entering clinical trials, in which the seed funding and ideally some of the capital from the exclusive licensing would go towards.
Okay, so just to give you some numbers, I ended up taking a device through with a client for, it was about 2 million in seed funding plus government match and additional non-dilutive funding for another 50 to 100% on top of that. And it took us about 2 years. And that was about as lean as you could get. So I don't know exactly, I haven't dug into your numbers, but 1 million seems light.
Thank you. And any other questions?
Just a quick question. Thank you for your presentation, Shiraz. Just on the, just kind of an additional question to the previous ones in terms of the funding. Would you see any additions to your team, either on the R&D side or on the business side?
Yeah, that's
as part of that?
That's a great question. So on the business side, definitely. When I came to looking into the pre-seed funding, I wanted individuals who just provided more than just capital. For example, when it comes to Front Row Ventures, they have individuals who are very experienced in areas such as this. So when it comes to getting a variety of investors from the pre-seed funding round, I would be expecting individuals to be added to the team.
Okay, thank you.
Excellent. Well, thank you very much. Excellent presentation. That brings us to the end of our second round and the second round of 2 of the finalists. So before we go further, we have a poll for the audience. So the audience can pick a winner. And we should have a poll rolling out here shortly by, there you go. Just a couple of more seconds to make final selections. Okay, I think we're ready to proceed then. So next on our agenda is our second keynote speaker. It gives me great pleasure to introduce Jeffrey North, who's the Vice President for IP at Intellectual Property Ontario, or IPON.
Just bear with me for a second while I see if I can share my screen.
There you are. We have it and we can hear you, Jeffrey. So please go ahead.
Okay, so you can see just the full screen here.
Yes, we can. Yep.
Okay, that's excellent. Thank you. You know, first of all, I just wanted to say that I've been incredibly inspired by all the competitors here today and the great technology that they've created right here in Ontario. And I think in that respect, it's important for me to give you a little bit of knowledge about my background. So I've been an IP lawyer, an agent for over 2 decades. So I've been involved in a lot of patent, industrial design, and trademark application drafting and prosecution. I've been a patent litigator for many years. So I've practiced in firms. I've also been in-house counsel where I'm helping with a lot of agreements, and most importantly, helping companies on their commercialization journey. And in that respect, I've helped a lot of companies work with researchers at universities. So when I'm seeing all the competitors here tonight, I think we're in good stand, you know, moving forward the technology in this process, in this province. The other thing I want to say is I'm also very impressed by the nature of this competition, because I think everybody has to realize all the competitors here, they've had to do a detailed technology summary. They've had to do a business plan with sort of a commercialization strategy, and then they've had to prepare for and do this pitch. And one thing that I think I should say here is that I hope that the commercialization strategy that each of the competitors has done has had a particularly important component, and that is an intellectual property strategy. And without it is a huge topic, and I don't think we can go into detail here tonight, but a patent filing strategy is not an intellectual property strategy. And so this is part of the reason, in part, for the creation of Intellectual Property Ontario, or as we call IPON. And it's to make sure that we're furthering IP scale up and commercialization efforts right here in the province of Ontario, to make sure that we can retain IP here and have a successful IP ecosystem in the province. So with that in mind, I'm just going to go through some of my slides here. Now, this is a couple years old now, this slide, but it's important to note that intellectual property and data are now the world's most valuable business assets. And so if you look at the S&P 500 companies, which are generally the largest companies and most valuable companies in the world, 91% of their value is in their intellectual property, whether it's their patents or otherwise. And also why IP matters. A lot of the competitors here tonight, they're talking about how they're going to raise capital, what they're going to do with their exit strategy, just how they're going to proceed exactly. And here are some interesting stats. The average VC deal size for startups is $6 million for companies with patents, compared to $3.5 million without. VC funding that went to startups that had patents, 58% compared to 42%. And VCs that went to late stage companies are 81% of those companies with patents, compared to 19% without. And for those companies that exit via IPO, it's 23%. It's more than 5 times the rate than those companies without patents. For acquisition exits, the median exit value for patent companies is approximately 155% higher than it is for non-patent companies per year on average. And I've got a quote here from a friend of ours, Roger Sadler, who's the managing counsel at Mercedes. So he's often working in New York, but he's up in the Ottawa area as well. And for our auto launch, he participated. And what he said to people when they're asking questions was, if companies don't have their IP protected, it is going to raise eyebrows and we'll want to know why. In some cases, it may be a deal breaker. And what Roger's talking about there is whether they want to invest in companies, whether they want to acquire them, license their technology. And so obviously what Roger's saying is you got to get your patent strategy in place. So with this in mind, the Ontario government had an expert panel, and it started in around 2018, 2019. Look at the IP ecosystem in Ontario and recommend how we can improve it moving forward. And they noticed numerous problems in our ecosystem. There's generally a lack of support for patenting and expertise on IP. There's a low understanding of the importance of IP, and some institutions, and this includes some universities and colleges, may not prioritize IP commercialization or a culture of innovation. And here's a quote from their expert report. They said, "Canada is the world's open source factory for ideas. We create it, but let others commercialize it." That's a problem, obviously. And of note, there's a lot of data showing that we were equal in terms of GDP with New York State for a long time. And then you could see where things changed in terms of patent filings. At this point, we're going at a much slower pace than they are, and that has had an incredible effect on the GDP numbers. And so we realize that we've got to improve how we're doing things in the province. And as a result, what happened based on the expert report was there was the creation of Intellectual Property Ontario. And we're a provincial agency that launched just in 2022. And in fact, we actually really just started operations in October of 2022. We're focused on providing intellectual property services and support to help Ontario businesses and researchers innovate and grow. And how do we do that? We provide up to $25,000 in funding for IP services. And we do that in respect with the help of a roster of vetted IP service providers. So we go through and we make sure that we've got some IP lawyers, patent agents, and the like, with a lot of experience helping our clients and making sure that they're offering their services on a discounted flat fee basis. We provide free IP mentorship and expert advice. And this comes not only from our rostered IP professionals, but we're creating right now a list of sort of entrepreneurs in residence who can help our clients with all aspects of their IP strategy. We offer education programs and have public events and resources. And like I said, we're a new organization, and so we're adding to our services as well. And so we're offering advanced education, and that will be starting in the coming months. And we're actually going to offer, it's a micro-credentialing course, essentially. So we can have students, researchers, the public take IPONS courses to make sure that they're up to a certain level of IP education, which will help in all sorts of regards for their businesses, whether they need investments and the like. We've also created sort of an IP benchmarking tool, and that can be used on startup companies. And it's almost like a mini audit where we can determine sort of the IP health of the company at an early stage. And so we can then direct our mentoring and our IP services to the companies based on the report that we get from our IP benchmarking. We're also offering IP intelligence. And in large part what this is sort of a patent landscape analysis. So when it's directed to different companies in particular, you'll see what your competitors are doing in the space, and you'll see where the white space is. Maybe where you can operate, where there's a niche market. And this is all it should be part of your IP strategy. And we're also offering networking and matchmaking services. So in that regards, I want to be able to help our clients, match them sometimes with researchers at universities who can help them. And I've done that in private practice when in-house before very successfully, where we're able to match the company's needs with researchers at different companies, universities in Ontario, to sort of set up centers of excellence where they can prove their technologies and show why their technologies are better than what their competitors are doing. And that's often the sort of thing that you need in order to help with your technology and show investors why they should be investing in your company. And then lastly, what I'd like to offer to all the competitors in this Proteus competition, we don't choose winners and losers. So I would honestly like all of the 10 competitors to go to the IPON site and apply for our services. We're currently in a beta test phase where we're actually testing our services on 40 clients from the auto, artificial intelligence, and med tech sectors, but we're going to be scaling up late this fall, likely. So what I suggest is for the competitors in this competition to apply, and just so that I can make sure I know I've watched all your competition. And what we're going to do is we're going to make sure we're going to offer you some education. We'll get you some mentoring. We might be able to offer some patent landscaping services to you. But if you get in and apply, I would like you all to work with your commercialization offices there at your universities and try and create a startup so that they will help you to commercialize, it's the start process to helping to commercialize your products, your technology. And as soon as you have a startup, apply for our services, and hopefully we can get you in as a client, because we do have a mandate to work with different researchers at universities, and maybe we can get you the needed funding that you need to help you with your IP services your IP strategy going forward. So I look forward to hearing from all the different competitors. Please do this as soon as possible, and hopefully we can help you with your IP journey.
Thank you so much, Jeffrey. That was such an excellent message on the importance of IP and some help around that. Well, we will now take a second intermission to allow our judges to tabulate their final results, and we will return with the results. That will take exactly 5 minutes, and that will be 6:23. So we'll see you very shortly. Okay, we'll get back started back up again with our award presentations in just a second. I hope everybody's back online and ready to go. Okay, so the first winner will be for the Western technology for Western. And I have the honor of presenting this. It gives me great pleasure to announce the winner for the Western University technology is IRNA. Congratulations.
Also, I'm Saeed Begheri. I'm filling in for Scott Inwood. I would like to congratulate the team Lex Sensor for University of Waterloo's technology, team being Alvin, Selvin, Elias, and Bowen.
Thank you so much.
I'm Steve DeBravendier from University of Guelph, and I would like to thank both teams, Gash and Lee and Wonder Metal, for their wonderful presentations. But the winner today is Wonder Metal. Congratulations.
Thank you.
Hi, and I'm Heather Pratt from the University of Windsor, and I am very proud to announce today's winner for the Proteus competition. Both teams did an excellent job, but the winner today is L-Ion Technologies. Congratulations.
Hi, Dave. Think I'm supposed to go next. Is that right?
You are, Gabe. You're on.
That's what I thought. But I actually don't know. So I'm not sure what I'm supposed to say because I didn't get anything.
Okay.
So happy to have someone else announce, but I'd like to say congratulations to all the teams who contributed today, because I think it was a great presentation that everyone did. I'm just really impressed with the different ideas that people came up with. So I feel a little bit lost here.
Okay. Well, Gay, on your behalf, I will the winner for McMaster is Team Solar Medical Solutions.
Yay! Well done. Thanks, Dave.
Thank you so much.
And I believe last but far from least, we have the audience choice winner. And the winner of this prize is the Guelph team of Gash and Lee. Congratulations.
Thank you.
So I will wrap up just by saying, wow, that was, I heard inspiring, I would say energizing, that it was just so incredible to hear all of these phenomenal ideas. And to sum up the night, you've heard the importance of technology, intellectual property, innovation, and entrepreneurship as being critical to Ontario and Canada's success. It's also a lot of fun. So it was so great to hear from all the presenters today, and for the opportunity to experience all of those items together is just an amazing opportunity. I wish I had that opportunity when I was an undergrad. Phenomenal job by everybody. I think the experience is awesome, and the ideas and business plans were really incredible. So thank you very much. Thanks to all of the presenters. Congratulations to the winners, but really thanks to all the presenters. Thank you to the judges. A big thank you again to our sponsors. Without you, this wouldn't have been possible. And finally, thanks to the team at World Discoveries that did all of the arranging behind the scenes and all of the presentations. It went very, very well on such a complicated set of Zoom technologies to work through. So thank you to everybody. Looking forward to next year. That concludes the 9th Proteus Innovation Competition. Thank you all.